Hi guys, I just thought I'd do a little bit of a podcast here for you to make sure you're on track with our experiments. For some reason, there we go. It wasn't talking to the PowerPoint. Here we go. So I've knocked up a quick little PowerPoint, and I'll just talk you through some of the things you got to think about when you start preparing this report. Remember, you don't have to write a written report. You can look at maybe producing a video report or a poster if you like to, but you want some images for that too. So bring those phones to class, basically. Now, I've given you an hypothesis to work with. Basically, I've said to you that we can make rockets from sparklers, and then to keep the cost in hand, I've given you one packet for each group. So we've ended up with sparklers with 2, 4, or 6 packets of energy, if you like. And then, of course, we forgot the fuses. So you've now got 15 sparklers to work with to make a decent rocket. Today we have some interesting non-events. Let's see if we can do better. There's plenty of energy though, wasn't there? So there's 3 laws of motion. The first one says that an object remains at rest or in a constant state of motion until acted upon by an equal or greater force. So at the moment, and I was going to try and draw these, but I can't get the software to work. At the moment, we have a rocket sitting on a launch pad or the basketball court, and we're applying a flame to the wick, but it's sitting still. It's not going anywhere, and it won't until the force of that eruption of the fuel source causes it to. So it's quite happy to be at rest. Okay. Newton's second law is basically always reduced to force equals mass times acceleration. So we need enough force to accelerate the mass of our object, which is why weighing our rockets would be a good idea, because you have some data to use then. But also it means we have to find how to get enough fuel into our rocket without causing it to become too heavy. And clearly we need to seal the rocket without making it too heavy. So it's a little bit tricky getting this thing to work. They do work. You can go on YouTube and find plenty of examples, and lots of them don't work, of course. And then Newton's third law is the most important one to us. Essentially, it's saying that for every force, there is an equal and opposite force. So again, I was going to try and draw a diagram I drew for you in class on the whiteboard, but I couldn't get my tablet to work. So here in this diagram, you can see all that energy, that smoke and the flame pouring out of the bottom of that shuttle, or actually the rocket the shuttle's attached to. And as that force builds up, it will start to take off. So the force of the eruption is going in one direction, downward, causing the force to push the rocket into space. And then we get outside the gravitational pull of the Earth, the fuel's all spent, but it's escaped by then, it just keeps on going. So for us, we need to make sure we've got enough fuel in the form of sparklers to cause enough energy to push down on the ground to cause the rocket to go up into the sky. And for that, we need to make sure that, as you can see here in this diagram, the only place the energy is coming out of is the bottom of that rocket. There's nothing going sideways. All the heat is coming down. And that's what we need to see on our rockets too, which means we need to seal up pretty carefully without making them too heavy. There's a lot to do here, isn't there? So the aim of your experiment is to test which rocket travels the furthest. That means you need to make some measurements somehow. Again, filming them would be good, particularly if they actually go somewhere. With the method, you need to explain how you measure rockets, of course, and then how you went about measuring what you're doing. So how you set fire to them, and how you measured how far they went. So far, that doesn't cause any problems because we've just produced a lot of heat. The poor old plastic tube we used today was well and truly finished with. We had to throw it out. There's a lot of heat from just a couple of sparklers. So remember, you should be re-weighing your rockets to get an indication of how heavy they are, because that will tend to help you with analysing what happens if we get some success. I gave some equipment. I gave you matches, 15 sparklers. I know, 12 the other day. Cardboard, some tape. And what else did you use? So Joey asked for some alfoil. Now that's wrapped around his rockets reasonably well, but will it be enough to keep the heat in? we'll find out. Today's didn't quite work, although it fell over, so that may have not helped much. Then when you come to risk assessment, you need to think about risk, because there's quite a few here. I mean, I've given you scissors, and they're sharp, and we need to be careful with scissors all the time and don't hurt people. We've got matches, so there's heat and there's potential to burn somebody, and of course these rockets. So I sort of took care of the concerns around rocket by asking you all to sit around the outside of the basketball court, and we set the rockets off in the middle of the basketball court, and I explained that we had to keep an eye on them because if they fell over, we had to get out of their way. So far we haven't had anyone take off, but that doesn't mean we won't. These have the potential to fly. It's just getting all the factors right, which so far we haven't done, but you never know. Tomorrow could be the day. There's some good rockets in that box. And then your results are telling us what you recorded. So you should have here a table with how many sparklers, how much your rocket weighed, and hopefully how far it flew. Well, hopefully. So it's just easy. It's a table of information giving us your data. And then in your discussion, if we have data, we can actually graph the weight versus the distance flown versus the number of sparklers for each of your rockets. And we can produce some graphs. And you can talk about, okay, here's these 3 laws of motion that Newton gave us. I can explain what's happening to my rocket using those. And of course, so far we've got some good conversation about what went wrong, and some thoughts already about how to make this experiment work better. And as I have said to you, if you're really keen, then there's no reason why we can't ramp this up and let you spend a bit of time over this term and next trying to get the best rocket, because you'll go do a lot of great science trying to make it work, and I'm more than happy to see that happen. Anyway, hopefully that helps you with preparing your report. Remember, it doesn't have to be written. Written's probably the easiest way in some ways, but you can make a video. You can maybe make a poster if you need to, or set up as a PowerPoint. Use this PowerPoint as a starting point, so you've got your headings and just write slides, if that makes sense. And of course, with the PowerPoint, you can put in videos and snapshots of what's going on from your phones or cameras if you bring cameras in. I'll see you tomorrow morning. Let's hope we get some great takeoffs. See ya.